1. Take a random sample from your data with replacement. So that means you put your sample size, your entire sample, like the one we have that I just generated, and you randomly sample, take a random sample of size n from your data with replacement. So all the possible data points are in the hat, and you're reaching in and picking one out and recording it. Then you put it back in and you pick again. So you're going to get a similar sample, but you're not going to get the same sample, because some of the n things that you pick out of the hat electronically are going to get repeated, and some of them aren't going to appear at all. Some of them might appear multiple times, 3 times, 5 times. Who knows what's going to happen? It's all random. But you're going to get a different sample. Of course, it's possible, statistically possible, that you get exactly the same sample. But it's almost impossible. So you're going to get a different sample. Compute your sample statistic for this new sample. This is why it's called resampling. Originally, you'd probably have a sample, your data was generated as a sample from some population. This is resampling. So this generates a new m hat sub 1, which is different from that original sample median. Question?
So with this, your bootstrap sample n is the same as your original sample?
The original sample size, yes.
Yeah.
So it's a sample size n. And there are variations on the bootstrap theme that make it different than n. You don't have to do n. Traditionally, you do n.
Okay.
You can do more than n or less than n, and there are some reasons sometimes why you might do that. But in general, if someone says they bootstrapped it, this is what they did. So now I have this m1 hat that's probably pretty close to m. But if my data is really weird, then maybe, or really variable, maybe it's not close to m hat, or depending, it's something. Then, repeat this process lots of times. Say 1,000 times. No fun if you're doing this by hand, but easy if you're doing it by computer. And they resulting in M1, M2, M1000. All of a sudden you have 1,000 medians that we're going to use to make a confidence interval, or make a p-value, or whatever the heck we're going to do with it. There are lots of ways to use these values. Now let's go over here. Let's do because I'm talking about a confidence interval for the median, I'm going to do a bootstrap confidence interval. And there are multiple versions of bootstrap confidence intervals in this case. The easiest one to understand and to talk about is called the percentile bootstrap confidence interval. And it says you just use the percentiles of those 1,000 medians to make a confidence interval. And so this goes by sort the 1,000 m hats. And that gives you, in statistical notation, m hat sub 1, m hat sub 2, dot, 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 m hat sub 1,000. When statisticians put parentheses around the values, that means we sorted it. So M1 in parentheses is the smallest of the 1,000. And M hat sub 1,000 is the largest of the 1,000. Then your bootstrap confidence interval is M. So we want 2.5% of the way from 1 to 1,000. So 1% of the way would be 10, the 10th observation. I'm trying to do this math in my head. What's the 2.5th percentile out of 1,000? And that would be the 25th one. M hat sub 975 is a 95% confidence interval for the median. I use the data to make a confidence interval called a bootstrap percentile confidence interval. And you will see in practice when people do this that if they're good at describing what they did, they will say that they'll put the percentile on there. But half the time, people just write that we bootstrapped it and found this confidence interval. Well, there's a bunch of different bootstrap confidence intervals, because for 30 years or whatever, we've been writing papers about the bootstrap. And there are literally hundreds of different versions of the bootstrap, all of which are best in some setting. This is the easiest version of a bootstrap confidence interval, and it works pretty darn well. It makes a good 95% confidence interval. By the way, what does good mean? good means that what's the real definition of a confidence interval? If we were to do another sample, then 95% of the confidence intervals would contain the true parameter. You should know that, by the way. Most people don't. Most people think I don't know, they have all sorts of crazy misinterpretations of what a confidence interval is. And no one likes the interpretation of a confidence interval. Everyone likes to think the confidence interval, most of my data is in that interval. Not true, completely wrong. Not even it. And the bigger your sample size, the worse that interpretation is. If you want to know what contains 95% of your data, just look at the percentiles of the data and you'll find that out. But that's not a confidence interval. Confidence interval is trying to tell you where this unknown median, M is the population median. And you should be able to describe this to other people, this confidence interval stuff, because now you're an applied statistician. And we'd like to get an idea of where this is. And that's what the confidence interval tells us. Not mathematically, no, that's not what it tells us. But in practice, you're confident, that's the incorrect interpretation of the confidence interval that sort of works. We're 95% confident that that interval contains M. And that's what we teach the Stat 210 students. The lowest